Okay, so I started recording and I uploaded all the videos. You got the link or
Yeah, yeah, sure.
okay? Okay. So I'll be uploading these slides as well. Okay, so you can
Yes,
check
yes.
them out.
Thank you. Yeah.
Okay, so today is basically the. So today what we are going to discuss about is. Wait a minute. Right. So today we are going to discuss about Java Datetime API and File IO APIs, which have been introduced newly in Java 8. Okay, and they help a great deal in solving some of the complex problems earlier which developers used to face. And so these APIs basically what they have done is that they have exposed many useful functions, right, which for which developer was actually dependent either on an external library like Joda time, or uh, they had to, and file IO is a bit different, right? So I will talk about file IO in a bit, what different they have actually done, and then we will touch base very briefly upon parallel streams. Um, so, like I said earlier, right, that it's more important to understand streams, and parallel streams is primarily an extension of the streams itself. Okay, but their working nature remains same. The only thing is that parallel streams basically they divide the task into multiple small streams, and then they combine the results together in order to get the final output. Okay.
Yeah.
Now, okay. So let's have a look at what, and and then towards the end, we'll take up any questions, or you want me to revisit any other topic which is confusing or anything. Then we can do that.
Okay.
Okay. So today we'll go bit slowly and try to understand the usefulness of these new packages. So earlier, the problem with daytime APIs was there were a couple of problems, right? They were not thread safe. That was one problem. The design of the earlier APIs, and many people have already felt let down with the earlier API till Java 7. That there was inconsistent design. Like default date start from 1900, so month will start from 1 and the day start from 0. So it was very confusing as to what to make out of it.
Mm.
And then there was very difficult time zone handling. In fact, there was, I believe, there was no time zone handling at all in the earlier daytime API, right? We had to be dependent on the external libraries. So as you said that you are already using Joda time, so Joda time is probably the most popular uh, daytime API library that actually solves some of the problems. Right? So we will look at what new daytime APIs are now, and then okay. So I have prepared few examples. What I will do is that I will create one more project as I. So okay, so let's look at what daytime API actually provides. So what I did is that I have already included this some examples here, and again I will check in into the same repository. By the way, were you able to access the repository? Is there any issue, or you are able to download the code?
No, I can download.
Okay, okay, great. So Now coming to the datetime API, before we start writing some code and looking at the examples, um, I want to briefly touch base upon some of the classes and packages that this library is actually exposed. Okay, so in Java.time, there are multiple classes that have been exposed, right? One are local classes, then there are zoned classes, then there is a class called periods, and there is a class called duration, right? So these are the four major uh, category of classes that have been exposed in Java.time. There are other useful classes, but these are primarily the most important ones. Okay,
In
uh,
Java dot 9 or 8?
Java.time. I
Uh,
didn't get it. I mean, what did you ask me?
I didn't get you like Java 9 or 8.
Eight, Java 8.
Okay, okay. Because you were talking about 9, that's why I got confused.
Okay, sorry about that if I sounded that. So Java 8 basically has these category of classes which actually help you deal with complexity of time in day-to-day operations, right? So if you utilize this, you will probably be able to get most of the functionality that is available in Joda time. Probably not everything because Joda time is a vast library, but still it will do the job in many of the cases. Okay. So there are two types of classes. One are local classes and there are zoned classes. Local classes are the one that deal with your local machine, right? So I mean, they actually pick up the time zone and other information from your local setup and where the program is actually running. And
Hmm.
zone classes basically they deal with the specific zone. Right? So if I want to convert, let's say, one time zone to another time zone, then zone classes are the one that I should be utilizing. Okay, they have APIs which actually specifically deal with this kind of complexity. Then there are periods. Okay, so period, as you can understand, right? Period is a so period and duration are basically similar in nature. Okay, so period is also a type of duration, and duration is something that is actually the time elapsed, right, between two different instants. Correct? So
Hmm.
you have instant one, you have instant two, and you want to find out how much duration actually elapsed between these two timestamps. Then what you do is you use duration classes, duration helper classes, and that will actually give you this time elapsed between different timestamps. Period is also same. It also gives you the difference. The primary differentiation point between periods and duration is that periods basically deal with the date based amount of time, right? So when you are dealing with dates, for example, you want to find out how much time, how many days actually elapsed between 1st January 1996 to 1st January 2015, right? Then you will be dealing with the periods, okay? But if you want to
Okay.
find out how much time actually elapsed, and which is like 1 a.m. Uh, till 12 p.m., right?
Yeah.
So if you are dealing with time, you will go with duration. If you are dealing with dates, then you will go with periods. Okay.
Yeah.
So the distinction there it is, and between distinction between local and zoned is that local is not worried about the time zone at all. Zone, so basically it is assuming some time zone depending on your where you are running your program. Zoned is something that is specific to time zone. So when you have to do complex time zone handling, when you have to convert time between different time zones, then zone classes are the one that you are actually going to use. Okay. Now local
Okay.
classes have further if you say local, so they are local date, there is local time,
Yeah.
there is local date time, and there is instant. Okay.
So, like, one doubt is like, Is it possible in Java 8, like whether we can uh, like based on the country they choose from the drop down, the whole globally we can change the time zone so that the whole application will run in that particular time zone. Whenever they keep changing the value of the country option in the drop down, uh, globally, it will affect everywhere wherever the date comes into picture.
Yeah,
Is there an
so I believe that
yeah?
for that you will have to use the Java 8 APIs to write your logic that way. Okay, so whenever you are doing time calculation, you take zone into consideration. So you use zone classes, and
Hmm,
you basically take zone as a parameter from the UI in all the APIs that you are actually utilizing internally. So I don't believe that there is something out of the box that you can do something like this, but yes, with the help of these classes you should be able to achieve what you are looking for. But you will have to design the program in such a way that it actually takes zone into consideration.
hmm.
The only thing
But globally, everywhere, if that has to get changed, then that may not be possible. Like, I'm not sure whether it is possible that change on one area something that then the uh, that change will account in everywhere. Just like if we change the server time zone, server time, then it will affect the whole application or something.
correct.
Yeah. So is it something like in Java we can do it just changing on one area that affects everywhere?
Okay. Yeah, I understand your point of view definitely, but at least I am not aware of that Java 8 should be able to take care of this scenario like automatically. I think you will have to write some code using the
Okay.
joined APIs.
Okay.
Okay. All right. So okay. So local date class, as you can see, local date is a class. It deals with the date. Uh, so it does not have any time component. Local time primarily has only time component. It doesn't have any date. And local date time is like a timestamp, right? It has a date and a time. Okay. And
Okay.
instant is a new class that represents basically a timestamp in UTC at that point of time, right? So you say that, okay, I want the value of this instant, right? And so I mean, you are so basically the name of the instant is that it's being made bit different from the timestamp because it has been standardized for UTC.
Okay.
So instant always gives you um, the timestamp corresponding to the UTC. That is the primary usage of instant. Okay. So we'll go through some examples of dealing with, and I have again written some daytime example class. You can see. So what I will do is will write the same thing. So let's try to get a local. So what we do is, let's look at this class first. So local date class has a helper function called not dot now, and this should be able to give you the current date.
Okay.
Now what I will do is, so if we debug this program, let's see what do we get. So if you can see, what I get is 2016, right? 612, right? So I get the exact same date which is there on my machine,
Yeah.
right? And this is something that I cannot do anything about. I will always get the date corresponding to my local machine. If I change the time zone here, let
Yeah.
me let me try to do that, right? Let's see what it actually does.
It will change, right?
Sorry. Sorry. Let me run the program again. Okay, so I think okay, so right. So I set my time zone to US, and that I get the date that I get is 11, right? So
Yeah.
so this always works according to the local date time preferences, right? I mean that's the now let me change it back. Correct. So local date time, if you look at, some of the we can have a look at what kind of function. So it has definitely now, and then one. So primarily, if you see, these are the kind of helper functions which are there in Joda time also, right? So its design is basically influenced by that library heavily. Okay. So what you can do is that if you want to get a specific local date, specific date equal to local date dot off, right? So now what you can do is and then past month and third day. So so I will get a so these helper function basically will help me create a specific type of uh, specific sorry so this helper function will help me create a local date object, right? So if I need somewhere in my program that I have to actually create local date, if I'm passing it to some other function or I'm dealing with date in some other fashion, then I can utilize these helper function. Okay, and it has couple of overloads. So what it will give you is, so I'm looking for some important function which we can discuss. As you can see, like the create function is generally private. It is called by other helper function. So the dealing with dates, I mean, they have tried to simplify in some fashion at least. There is one more function that I want to. Now it also has one now function, and now function basically what it does is zone ID, right? Now zone ID is something that has been actually um, it's again a helper class in java.time. Earlier this class was not there, so these zones are well defined, right? So if you want to get the date of, let me see what time zone is. So what I can do is, I believe this is the correct time zone. Manjush, can you hear me? Hello.
Yes, yes.
Okay, sorry Manjush, I lost you again.
Yeah.
I've been complaining about it, but I think they will take their own time.
Yeah.
So basically, what I was trying to say is that there is one more utility function as part of the local date, which deals with that time zone. Okay, and generally, if you see that they have tried to simplify these functions as well, right? So now, what
Okay.
now? Local date now it takes basically a zone ID. Zone ID is basically a class, right? And if you see that inside the zone ID, they have
Yeah.
these different time zones, right? Okay.
Mm.
So the whole, so what I can do is I can pass one of these and I should be able to get a date for this particular time zone. What is the time zone of Ireland?
Uh, IRE. I am not sure.
Okay, let me. So what I get is if you look at my debugger, local date I am getting as to 12th of June, right,
Yeah.
2016. The specific date that I created just in case if my algorithm needs a local date, then that I get is 2015, whatever I argument I gave, and the US date is basically 11th of June, right? Because I changed the time zone
yeah,
in dot now function. So all these have been actually given a short expression also. So for if you say America Los Angeles, it has PST. Generally, it follows the ISO standard 8601. Okay, so dealing with this shall not be a problem here. So now, so this is my local date class. Okay, there is nothing much about it about the local date class, but as you see that it basically tries to lay a foundation for the simpler date time handling, right? And if we
yeah,
talk about local time, then let's see what does local time does. And beauty about all these classes is that they generally expose static functions, right? So once you say local time dot, then you would be able to get the helper function that you are actually looking at, right?
yeah,
Now, if I say local time dot now, as you can see, as with the previous API, I should be able to get the local time, correct?
yeah,
What I will do is this local date time, local time. So by the way, I'm trying to write these functions so that you can understand at later point of time. So if you need any comments or any hint during the discussion, then let me know. I will include that right as part of the code itself.
yeah. Is there any role for the JDK? We can set the time zone for the JDK.
You want to know the current time zone, right? Where the so I think you should be able to get that from the. I'm not.
Like instead of depending on the machine time, we can set the time. We can set the time zone for the JDK or Java, so that even if we change the server time zone, it won't affect the application.
Okay, okay. No, I got your point. So I believe so. Right now, I do not have an answer for that. Okay, so, but what I can do is that I can actually find, but I can find out and send it to you. But one thing that I want to say is that it has got nothing to do with the new datetime APIs. It
Yeah. Okay. Okay.
if it is there, then it is part of the runtime right from the beginning of Java, right 4 or 5 or 6 or 7.
Oh, okay. Okay. Okay.
But I'll find out and answer to that question on the email itself. That works.
Yeah.
Okay. So what we are getting here is if you see that the when I ran the program, this is what I get: local date and local time, right? So local time is 10:08 because I ran the program a while ago, but let me run it again so that we get the correct thing. So I get right.
Yeah.
You can see this, and this is the same time as on my machine. And just like my previous APIs, so now the design is consistent, right? So there is a now function in local date and there is a now function in local time, correct?
Yeah.
So it becomes much easier for me to identify that what API actually I have to call. Now, if I am able to pass a time zone inside the local date dot now function, then I should be able to do the same thing on local time, right? That is my expectation with the new
Yeah.
API. So let's just see if we have same local time, US local time. Equal to local dot now. If you see that now actually has a zone ID, right? You saw that, right? Sorry.
Okay.
So now I've got three overloaded function. One does not take any argument, which means I will always get the local machine time. Another one basically takes a clock, which is rarely used, and third one is which is takes the zone ID. So
Okay.
what I will do is that I will pass the same zone ID here and then see what time I'm actually getting, right? Let's just, so as you can see in my debugger, right, the US local time that I'm getting is 9:41, right? So
Okay.
it's 9 p.m., 9:41 p.m. That's what I'm getting, and let me see. As you can see, it's 9:42, right?
Yeah.
So we are pretty close. So it's basically giving me the correct. So in a very easy manner, I am able to get the time of a particular time zone, right? So just in one line of code, and that is the beauty in the new daytime APIs. Earlier, I had to struggle like which class I have to call, one what format do I pass the time, how this happens, how that happens. So right now we are getting date and time separately, right? Because we used both the classes separately. Now let's try to have a now let's deal with the local date time, right? Local date time again gives you date and time both the components. Okay, and local date time. Now what I get? Local date time. Now again, like I was saying earlier, that because Java claims that there is consistency in the new Java datetime API. So when I say dot now, I should be able to having a now function inside local datetime as well, right? And
Yeah.
you see that now has actually the exact same signature as it was there in local date and local time,
Okay.
correct? So now, as you see that in the design there is great consistency. And if I say dot now, what I will get is correct. Now what you see is, so is it clear to you now? You can see. Let me run it again.
Yeah. Yeah. Getting the correct night and time, right?
So in when you deal with the local date time class, what you get is a date component. If you can see it here, so I get the local date, and this timestamp, this T basically it's a ISO standard. So this is what you get the format in the ISO standard, and you get the local time as well. So when you have to deal with the date component, you use the date class. When you have to deal with the time component only, you use local time. And when you have to deal with date and time both, then you use the local date. Correct?
Yeah.
And again, with this thing, we can what we can do is we can also get a time specific to a time zone. US date time if I want to get, then I can. And now again, if I see now we'll basically have a zone ID. And zone ID, I know how to get the zone ID, so I can simply pass this. So if I run it again, now US date time should be able to give me date and time of Los Angeles, right? Now if you see my debugger, right? So you get the date component and you get a time component. And if you see, local date time is nothing, but it's a wrapper on top of local date and local time. Okay, so local date time basically create has a member called local date and it has another member called local time. So it combines both the components to create a date time, right? So it's a simple thing. Got it?
Yeah.
Okay, great. So okay, so this is about the local date time. Let me see, if there are any important. other example that I need to cover with respect to local date time, because right now let's look at the another problem. Okay, let's look at the problem of formatting, right, which is a common problem with the dates. Okay,
yeah.
public string get formatted date. Okay? Now what I want to do is first I want to get the local time, which is this. Okay, and then let me try to convert it. Sorry, local date. Let me get it now. Let me try to convert it to some other popular ISO format. Okay, so let me see. Do you have a particular format in mind? Do you want?
Month, date, year, hours.
Let me see if there is any interesting format we can get.
MMDY or something.
Mm, okay, let's do that. Local date dot. Now, if you see, there is a format function inside local date itself, right? This takes a date
Yeah,
time formatter. Okay?
yeah.
So date time formatter has many. If you see, it takes standard.
Oh,
Right? So basically, this thing has been again, has been greatly simplified. That I want my time to be in ISO date time. So basically, it will be able to give me without actually doing much of coding. But if I want uh, standard pattern, right, which is not
yeah,
there. So what I can do is, let's say MMDD, right?
yeah. Maybe you can write capital double up so that three
Sorry.
in three capital MM.
Yeah. Let me see what does it return. Correct. So I get 6/12/2016, right? But if my local date, if I see, it was actually 2006. It was YYY MMDD. Now I am able to
Yeah,
convert it to MMDD YYY, right? Or I can convert it to any other format as well. Okay.
yeah,
So this is how I get the formatted time, right? So it becomes much simplified. Correct. Uh, that's the primary objective of the new Java.datetime API. So let me see if I think so. This is all about local date. I don't think there is anything interesting here other than this. So there are some other examples that I have included here that you can have a look at it. But primary objective of these APIs remains same. Right? So it also has a what you call the parse function, and this parse function basically. So if you look at the parse function, you give a time in a string format in this format, and it will be able to give you a time which is of type local time. Okay? So you can basically once you get the local time, then you can extract hour, minutes, and second out of this particular string. You don't have to do custom split on this column and do some stuff on your own. Okay,
yeah.
so So we created basically date, we created time, and we also work with the date and time, correct?
Yeah.
And we have already looked at how to work with different time zones, right? And right. Okay. Now, so basically, now the zone time also takes care of the daylight saving. Okay, so you don't have to do write any specific logic for dealing with the daylight saving.
Yeah.
Okay, so you can safely assume that the zone date time API is, this is able to handle all daylight saving related complex scenarios behind the scenes.
Basically, it will automatically change the server because it is picking up from the server
Yes.
or from the local machine. So once time will automatically, if it automatically changes in the system, means it will pick that date only, right? So no
Yes.
problem.
Yes. So now, yeah. So now basically the everything has been simplified. Earlier, we had to like people were always confused while using this daytime API. How to what kind of scenarios we have to handle, what kind of scenarios are automatically handled. There was no consistency in the design itself. But now it's like cakewalk in order to deal with different time zones and in order to understand what APIs actually have to be used just by following a consistent design. Right?
Okay.
Okay. Sorry. Now what I have here is okay. Now let's look at the zone date time. Okay. So zone date time, like I told you earlier that it specifically deals with the zone related issues. Now before that we go, let's have a look at what does actually instant do. Okay. So instant kind of represents an instant at that point of time related to UTC. Okay, so now instant is like a wrapper on top of timestamp.
Okay.
Okay, so I get a so generally, for example, if you must have seen use case, where we try to identify how much time a particular function is actually taking while executing, right?
Yeah.
So what we do is that we used to create a timestamp before the start of the function, and then we used to create a timestamp when the function is executed, and then basically take a difference. Correct.
Yeah.
So that part actually has been simplified by in this class called instant. So instant is basically this now function where which actually represents the current timestamp as per the UTC. That's the that's the most important thing. Okay.
Okay.
It does not take into account your local timestamp. It's basically deals only with the UTC. So from UTC, what is the instant now? That's the value that it will actually give you. And if you see, what I can do is, so basically, what let me duration. So I am taking two instants and I am trying to find how much time is actually elapsed between these two instants, right? Um, You can call it timestamp also for the better understanding, because timestamp is a more popular terminology. So instant dot now basically gives you the current timestamp, right? That was our understanding. Now I will wait for a while so that my clock actually ticks for a couple of seconds more. Right. So now basically what I get is a instant in terms of the seconds, right? So this duration basically helps me to identify now the only function that I called is between, right? And this between function takes a temporal. So it can take a local date, it can take local time, it can take instant as well, and it can take a local date time, right? I mean, that's the beauty about this function. So there is only one simple function which is basically giving me uh, elapsed time between two different times. Okay, so
Yeah, the one of the problem with this Jora time, like basically sometimes this we may have to pass this as a parameter for recovery or something. Then in certain cases the Jora time may not work. Then we may again have to convert that this to java.util.date.
yes, yes, correct. So, and one more
Then
thing
again,
I will see is that
then,
while working with Joda time, Joda time has like too many classes at times, right? I mean, you get confused what parameter you have to pass. So
yeah,
most,
that is the most confusing thing. Yeah,
so most of the time you have to like go through the documentation, and then again you start working with time, again you forget, again you have to go through the documentation, right? So this has been, I believe that at least in Java, this has been simplified. That you are not dealing with too many APIs and too many classes, and still you are able to do what you are actually looking for most of the jobs. But still, Joda time has like more functionality, and so if you are already having some code in Joda time, probably you don't have to change it to the current Java datetime APIs. But in future, if you are dealing with, then you can definitely have a look at it.
yeah,
Okay. So now we saw that what actually instant does, and then we have already seen that if we have to find difference between two different instants or two different timestamps, then the only function that we have to deal with is in between, right? And between basically takes a temporal, so it can take a local date, can take local date time or local time, or instant even, and the function is same, and you should be able to get a difference between two different times. So earlier, what was happening is that okay, I have to convert this object to that object, and then I have to pass this new object to the new library, and how to create one object from another object is another API that I need to look at it. At least in Yoda time, this is the problem that at least I feel I cannot vouch for everyone else, but at least this is what I get confused about every time I deal with, and I have seen most of the people, most of the developers they have to go through Joda time APIs again and again, right? So now let's see. So any questions so far?
no, it's a
Okay. Uh, Now let's see the zoned date, right? So what we are saying is, if we have to deal with specific zones, then I should be able to get help from the zone date time. Okay. So let's see what kind of APIs. And most of, like I was saying earlier, right? I mean, most of the time you'll be dealing with the static functions exposed from these API, right? So that is also consistent. It's not like that sometimes you have to create a new instance, sometimes you are dealing with the static API. So that part has also been kept consistent, which is I find very useful while right. So now zone date time also has a now function, which again takes a zone ID. So it is similar to what local datetime has, right? At least this function is similar. But zone datetime is generally more elaborated. So it also has a now function, which will again give you datetime in the current. And I have prepared some other examples related to this. Is if you want to deal with some other, so now you see this, right? Let me get this particular, let me call this particular function. So zone datetime dot off, right? And you have an off and you have an off instant. Off simply takes a local datetime and off instant takes the instant. Okay. So you do not have to convert instant to local date or local date time in order to deal with the zone date time APIs. If you have an instant, you can easily pass instant itself. Okay, and so let me do this. So I have a local date time, I have a local date time, and I want to convert it to some other zone, right?
Yeah.
So I already have a. This is also extremely consistent that all the time I have to pass the zone ID, and the way I get zone ID is from this helper function called off, and all I have to do is pass the convention for that particular time zone. So rather than the local date time, let me create a new date time. Let's say I do not know, right? So let's say 2016 1st of May. Okay. First May. So let's say I have this particular date in my local time zone because I'm getting a local date, correct? Now I want to
Yeah.
know what this date was in Los Angeles time zone at some point of time, right? So when I had 1st of May 2016, what was the date in Los Angeles? That is something that I'm more interested about. So zone, I what I'm doing is I get
Sorry.
local date, and I'm actually going to pass this in my zone date time dot off function. Okay. So by the way, this off basically takes a date time and not really a date because it has to find the, and in the off what I will do is, so I pass this timestamp, right? This is local date time, and I want to find out what was the date and time at that point of time in Los Angeles. So let's just see what it actually gives us. I get a zone date time. Let me go to the debugger. So my debugger basically it shows, you see this, right? So there is a 7 hours of difference,
Yeah.
correct? So uh, so I get 1st of May 2016 with 7 hour of difference, correct?
Yeah.
So so do you think that there is any confusing argument here in the APIs, or there is any complex use cases of these API which you are not able to understand, or do you think that it has really simplified the job of a programmer while dealing with the date time API?
Yeah. It is simplified, but I don't know like in query objects like Hibernate uh, and like any other frameworks with the or the JDBC or the plain that they accept this local date uh, or local date time, whatever is the example, or it should be convert again back to java.util.date. If we are forced to again, after doing all the date manipulations, and then if we are asking to convert again back to java.util.date or to long or something, then again the complexity comes.
So I mean, you are right. I mean, so those supported infrastructures like Hibernate, they probably have not been ported to Java 8, at least as of now. Okay, that's my
Mhm.
understanding. So they still deal with java.util.date, wherever they are taking these dates. So you mean to say, right, I'm passing date in query, and do I have to, what benefit do I get from the local date time, right?
Yeah,
So those have not been ported. I mean, because it will be a very big change for those guys, right, to uh, port java.util.date to local date time. But
I think they support java.sql.date also, and
correct,
but and I'm not sure. Some people they will always stick to long values.
right.
Yeah.
So yes, I mean
So
basically it has come very late, right? I mean, if you look at the design choices, um,
yeah,
Java has been there around for like for 20 years or so, and now date time has been the problem right from the beginning. So I would say that the introduction of these APIs have been very, very late, and the frameworks which are actually dependent on the dates, they will take some time to catch up.
yes,
If they,
yes, yes,
if they
correct.
decide to do that, if they decide to do that, they might not decide to do that because many of the problems they have already, done some workaround one way or other.
Yeah,
So yeah, so I agree on that part, but yeah, I mean, we are not the language designers, right? So we can only complain about it.
yeah,
Okay. So okay. So I think yeah. So we have covered pretty much of it. Do you want to take some break?
yeah.
Okay. So let's meet after 10 minutes.
Yes.
Okay. Great.
Thank you.
Hey Manjush.
Yes.
Hi. Okay. So I sent you an email regarding the question that you actually asked me. Um,
Yeah.
so if you want to launch your Java program in some other time zone, which is actually different from the default time zone on your machine, then you can pass it as a Java option itself. Okay.
Basically, that we are an argument for passing an argument for passing an argument for the JVM.
Correct.
So that one, so when we start the Tomcat or like when we start the application, when the JVM loads,
Yes.
this time zone will come into this time zone will come into effect.
Yes.
So but it is not happening during the runtime.
Yes. Yes. You are right. I mean, it is
Yeah.
set only once.
My doubt was like during runtime. So during runtime, if someone changes the location from India to US, then whether how the application, the date, other things
Okay.
completely get changed. So it's like we have internationalization, like we change the languages based on different. We can change the dates, the complete content to different languages. That features are there. So something like, so what about the date? So my doubt that always comes in my mind is about the date thing. So like how this date can be moved from one time zone to another time zone during the runtime.
Okay. Okay. I understood.
So yeah,
Okay, so yeah, so probably that we'll have to think about whether it can be done or not. I mean that also is a question, right?
yes, yes.
But yeah, your doubt
Maybe
is
some
doubt is
maybe some other option will be there because most of the web developers may come across like may have this type of applications for multinational companies or something when they have offices in different or factories or industries in different areas or localities or countries, then this situation may arise. But so far, I don't think there is a simple solution for this.
yeah. I also think so that probably there is no simple solution as such. At least not that one
Yeah.
I'm aware of. Okay, so now we come to our last part of the whole thing, and which is the new file NIO APIs. Okay. So before
Yeah.
we actually go into what kind of classes are there in file NI, what kind of functions are there, the question asks someone may ask that okay with Java datetime I understand right that there was a problem, there was a design problem, there was a consistency problem, there was some scenario which were not handled, so a new datetime API was needed. Correct.
Yeah.
Why a new file API is actually needed in Java 8? What is the primary motivation or reason behind it? Okay, so that part is probably even more important than looking at the API itself. Okay,
Yeah.
now if you so basically now Java actually introduced a new concept of IO, NIO, and NIO is basically nothing but a non-blocking IO. Okay, uh,
Yeah.
and non-blocking IO basically, so it's a very important concept, right? Non-blocking IO. And have you heard about a
Non
project called Node.js?
non-blocking non-blocking means
Yeah, so non-blocking, yeah, I'm coming to that. So have you heard about a project called Node.js?
pardon?
Have you heard about a new framework called Node.js?
Not Dodges. Yeah. 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 Yeah.
You have heard, right? Okay.
Yeah.
So Node.js, the primary core principle on in Node.js framework is the non-blocking IO.
Non-blocking. Okay.
Okay? And Java also has this capability for quite some time for non-blocking I/O and file new file APIs. They actually wrap the non-blocking I/O capabilities of Java. Okay, that is the
Okay.
primary purpose of these new file APIs. Now, coming to the what non-blocking I/O is, so that concept we need to understand a little bit, and then we will go into the specific classes. Okay. So non-blocking I/O. So generally, when we do I/O, right, whatever APIs you were having earlier in Java, buffer buffer readers, and stream readers, and all those things. They were basically what they were doing is they were reading a file. When you read actually a file, you block your code. What that means is until that operation is actually completed, you cannot actually go ahead, right? When you read a
Yeah.
file, sorry.
Yeah. Yeah. Please carry on. When we read a file.
When you read a file, until that operation is actually completed, okay,
Yeah. Yeah.
you cannot move ahead in your code. Your program will basically stop there until that operation is actually completed.
Yeah. Yeah. Okay.
Now,
Because that
program,
has to get because that has to get into the stream. Then only
yes,
further operations can be handled. Right.
yes. So there's the fundamental difference. Now, in a program, when you are dealing with a program, right, the program spends time primarily in two things. Right? One is CPU, another one is IO.
One is CPU.
One is CPU, so it program when it spends time, it
Ah.
either will be CPU intensive or it will be IO intensive, right? Or it will be a
Okay.
combination,
Okay.
correct?
Yeah.
So now a lot of people realize that IO is actually very expensive compared to the CPU. So many CPU
Yeah.
cycles are actually wasted while waiting for IO to happen.
Yeah.
And that time can be actually utilized to do something useful. So,
Okay.
so in order to get the better performance, it is necessary that we actually optimize this process of IO because we are doing IO lot of times, right? Dealing with the databases, dealing with files, working with, calling other APIs on HTTP. So, can we do something that can actually help us utilize these wasted CPU cycles and doing something useful rather than just waiting? Right?
Then why not to put it in a different thread?
So I am coming to that. So one way was that we can actually do it in a different thread, right?
Yeah.
Like you are saying. So we do it async. So that IO, you can call it vaguely like async IO
Yeah.
because you are reading asynchronously, right? Now the problem that actually happens is that on a particular machine, number of
Yeah.
cores are limited, right?
Yeah.
So we have 4 core or 8 core machines these days, right? So 8 core machine will be normal. And on those 8 cores, only 8 threads can run simultaneously in parallel.
Yeah.
Right? So more than eight
Yeah.
threads, they will always, create some kind of congestion. They will always fight for the resources. They will always try to, execute on their own by taking control of the CPU. Correct. So let's say you are. So what happens is that when you are doing async and you created a new thread, first you created a new thread and that thread creation itself was an overhead. And after that, when the thread is actually running, that is again trying to fight for the same resources for which other threads are actually fighting for. That part is like you are you getting that part?
Yeah. Yeah. I am involved in your discussion. Yeah.
Okay. So basically, what I'm trying to say is that thread creation itself is an expensive process, and when you create a thread, they can actually stall your program if you create like too many threads. So you can only have limited number of threads in a program. That's constraint number one. Constraint number two is the thread creation itself is an expensive process. Constraint number three is that when the thread is actually created, it actually fights for the resources, so it is actually competing, right, with other threads.
Yeah.
So the thing is that this process, and this probably makes more sense for creating threads when we are doing computation. But when we are waiting for the IO, right? So we just created another thread to wait for the IO again, right? Because the process will remain same. So in another thread also, we are still waiting. Even if you create a thread, you will still wait. You will still waste CPU cycle. That's the bottom line.
Yeah. Okay.
So you will be able to get some optimization out of your program if you do async IO by doing file reading and writing in another thread. But the point remains same, that even if you create the thread, CPU cycles are still wasted, because in that thread also you are still waiting for IO to happen.
Mm.
Okay, so your program application layer is basically what we say is blocking, right? This is what we call blocking, because compared to CPU, IO is basically many order of magnitudes slower, and that's the primary reason that people wanted to optimize it. And Unix kernel, basically they introduced this non-blocking IO. I don't remember the kernel version, probably 2.6 or something. And Java basically created a wrapper on top of it and call it non-blocking APIs.
Okay. So uh, but anyway, unless and until the whole mm, file gets loaded or read, we cannot do any processing based on that particular file, right?
Yes, you cannot do any, but you can do some other processing. Your question is perfectly valid. Observation is right. You cannot do any processing based on that particular file, but you can do some other processing. And that is why
Mm.
the design of the program remains in your hand, and you have to decide if there is any other part of the program that I can run which is actually not dependent on that file.
Okay. Okay.
Okay, and when that operation of reading files in a non-blocking fashion, when it actually gets completed, your program actually will be notified that my operation has been completed, file has been read, and now you can continue working whatever you wanted to do with this data.
So just like in threads, like or something like now the line for reading the file has come up.
Hmm.
So and it is taking time to. So we put it in a non-blocking format so that uh, it is not it is executing the next line
Yes,
or it is going to the next part
correct.
which so but after executing in the next part there is a situation comes like a situation comes like it has a dependency on the file that we are reading,
Yes,
some values that is reading from the file. Then what we will do?
yes. So that's exactly. So then you have to wait till that operation is actually completed.
So is that Java will wait or we have to set the values
So
explicitly?
if you are dealing, so that's exactly what the file API or new file API has done. If you deal with the Java non-blocking APIs natively, okay, that
Yeah.
means if you work with them on a lowest level, then you will
Yeah.
have to handle all these things on your own. But if you use the useful wrappers, useful APIs given by the new file APIs, then all those things will be actually taken care for you.
Oh, okay, 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 okay. Fine. Yes.
So you are dealing with the non-blocking IO, but still you are not writing any non-blocking IO specific code. You are only dealing with the higher level APIs, and that is the beauty of the new file APIs, and that is the primary reason I have taken it up late after the date time API, because those are probably not that important compared to this one.
Yeah.
Okay. So okay, now just have a more elaborated discussion about it. Let me give you one more practical example, which is of creating chat servers, right? So do you use WhatsApp?
Creating?
Do you use WhatsApp? WhatsApp
Yeah,
application?
yeah, yeah, yeah.
So WhatsApp basically, you So look at what WhatsApp does, right? So there are a lot of people which actually connect to a central server, right?
Yes,
And
yes,
the
yes, yes.
messages are basically transferred from one person to another person. And those
Yeah,
people are most of the time connected, but probably not texting all the time, correct?
yeah,
So what happens is that on the server there is a lot of load. There are a lot of people who are actually connected. So WhatsApp has
yes, yes.
around 500 to 600 million users online, right? At any point of time. Uh,
Yeah,
that's huge amount of load, and you need lots of servers if you are able to serve if you want to serve that traffic. So what
yeah,
non-blocking APIs what they do is non-blocking APIs that they know that a lot of people will be connected, but only some of them will be actually texting.
yeah.
Right? So number of people who are actually doing IO at some point of time is much less compared to the number of people who are actually connected.
Mhm.
So in order to deal with this IO, we don't have to have one dedicated thread for each IO, right? So when we are reading the data from the socket, earlier what we had is that we had one dedicated thread to read from one socket. So if there are, if there are a million people connected to the server, I am having a million threads running on my system, which is completely ridiculous, right? Because I cannot run a million threads in my system. My system is only 8 core or 16 core, maybe, right? So, in order to utilize the resources effectively, this non-blocking IO basically really helps because now what we do is that using single thread, because it's a non-blocking, right? Using single thread, we can read data from all the sockets because there are only few people who are actually texting, right?
Mm.
So this non-blocking IO, the non-blocking sockets, what they do is that they can deal with multiple sockets at same point of time using single thread, and that now it becomes very efficient because I have to allocate only one thread. I don't have to increase the thread in the same ratio in which the people are actually connecting to my server. Okay, and the only
Okay.
problematic thing
Yeah.
is that sorry, what? Yeah, you were asking something.
No, 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 no. I didn't ask.
Okay. So basically, what I'm trying to say is that, in order to optimize the resources, we spend time where it is actually needed. And just for creating a thread, just for waiting for IO to happen, that at some point of time in future, some person will actually send a message, then I will start working. And creating a dedicated thread for that is probably not useful mechanism. And this is exactly what chat server like WhatsApp or Google actually they use non-blocking IO extensively in order to utilize the system resources effectively. Okay,
Yeah.
so if we look at some of the differences between IO versus non-blocking IO is stream oriented, right? This part you already know. Uh, Non-blocking IO is buffer oriented, meaning you keep reading data in buffers. Okay, and once your IO operation is actually completed, you notify the application. Okay, and it is handled by the underlying OS layer. So non-blocking IO is something that has to be supported by the underlying operating system. That is the bottom line. Okay,
Okay.
so if you are using Java APIs on some Java non-blocking API, some older version of Linux which did not support non-blocking IO, then you will not be able to get any benefit.
Older version of Linux.
Yes.
Okay.
Okay, so let me, if you want, I can try to find out where exactly it was. And you can see that some people already actually tried that and they are getting this. Somebody has opened a question, right?
Mm.
And they say that odd behavior of java.nio on different Linux version. Okay. So it's very much dependent on the which Linux version you are actually using, whether you are able to get benefit from these APIs or not. Okay. So if I just to give you an overview, if you deal with the so this is one of the blocks, and if you want, I can actually send you the link, right? This reference
Yeah.
material. And if you want to go like bit deeper into how non-blocking IO actually works, then you can see that there are a couple of APIs, a couple of classes which actually deal with the non-blocking IO. So one is file channel, another one is datagram channel, socket channel, and server socket channel. Okay, and you have to deal with these low-level classes in order to get benefit of the non-blocking IO. And this code basically keeps getting complicated and complicated. Okay,
Okay.
and as an application programmer, you do not want to deal with that complicated code all the time. You want to work with some higher level abstraction, and that is exactly what Java file APIs have actually done. Okay,
Okay.
so what we will do is that we will look at these sorry these this package Java. So all the new APIs are java.nio.file package. Okay,
Okay.
now
So
what?
that N is for non-blocking.
Sorry.
That N is for
Yes,
non-blocking
and is
package.
exactly. Yes. Okay. So all these APIs are there in the java.nio.file package. Now, what we will do is that we will look at some of these useful functions and see how they actually work. Because it's part of the curriculum, so this needs to be completed. Now, what I will do is so first function that we want to explore is so files uh, have multiple static method, right? So this class is actually final. If you see, so you cannot derive a class from it. It has many static methods which actually help you to deal with different scenarios. Now, if you see, there is a function. If I want to find out whether there is a file that actually exists or not, so what I have to find out is I call this exist method, and exist method actually takes a path. Okay, and this path I have to create. So at my program, most probably what I will be knowing is the string of the path, right? I will not have a path object. So this path object I have to get from the string, and then I have to pass it to file exist function in order to so so what I am going to do is Hello, hello, hello.
Yes.
Yes, sorry, Manjush.
Yeah, yeah, no problem.
So basically, now the point that I was making is that the files class have many useful static functions, and this is very important, right? That all these important functions which are actually useful in dealing with these complexities, whether it is date time, whether it is related to files, they are primarily static functions. Okay, so
Yeah,
files.exist basically gives me um, returns me a boolean variable whether the file exists in a current path or not. What I'm going to do is, now if you see file.exist, basically it takes a path, right? Now I do not have a path. The only thing that I have is file path, right, which is a string.
yeah,
In order to create this, again a useful class has been created in the file in java.nio.package, which is paths. So when I say dot paths, basically what it gives me is pass.get, and I will just pass the path of the file, and this returns me a boolean. So here it is.
yeah,
And what I will do is, I will basically boolean and then I will give some random path. Now what I have is, so I have given a path to a non-existence file, and if you see, I do not have any file here, right? The only file that I have is folder1.txt. The name that I have given is the sum file.txt, right? So ideally, let's see what does it actually return. So it returns me false, correct? Which is as I expected. So now I did not deal with any file NIO APIs, right? But still I am able to work with file NIO APIs by using these helper classes that Java new APIs have exposed, right? Now there is some other, we have now files to check, delete, copy or move, right? So similar way, there are other functions. If I want to, so let's take another delete file, right? If I want to delete file using new Java file and IO APIs, I have string file path, and I should be able to, you see, again I get a path. So I say path.get file path.
oh, okay, okay,
Now it will basically throw an exception just in case the file does not exist. I will add it to the method signature itself. So now I will basically give a path to a actual file, which is folder1.txt. So if you see, this is what I get, right? Folder 1.txt. I will try to delete this one.
This Mac has the Linux terminal, or Mac has its own terminal?
Yeah, Mac has its own terminal.
In Mac, they have a Linux terminal.
Sorry.
Is there any option in the Mac to have a Linux terminal?
So basically, Mac has got many utilities. I mean, the terminal that you see is most. It's not a default terminal of the Mac. It's called iTerm. So
Okay.
it's a free terminal that I downloaded from internet, and it gives me like Linux-like feeling.
Okay. Okay. Okay.
If you
Okay.
see the original terminal of the Mac, then this is the original terminal of the Mac, the one that you are seeing right now.
Oh yes, 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 yes,
So it's
yes.
not. This
That,
is not very.
that's a good. Yeah, okay. Yeah.
So what I will try to do is that I will try to delete this particular file, and let's see. I don't want to get an exception, so I will just. So what I will do is I will give the name of the correct file. This one. And so again, like I said, here right now I have a file, but when I try to run this program after the delete file is called, my file should actually be deleted. Now let's see now. My file is deleted, right?
Yeah.
So again, this is a very handy, function. And after that, we have to look at. So we have covered check, we have covered delete. Let's try to copy, right? So obviously, when we try to copy, then we will have to have a source destination and a target destination, correct?
Yeah.
So string source file string destination, or rather, I should do source path. Again, the thing should come in very handy to me. Now, if you so this one, if you see this, the third function that I'm looking at, this one is actually a bit interesting. And if you look at the first argument, it takes source. Second argument, it takes target, and the third argument is actually option, copy option, right? So it's a class that has actually been created. So I will show you how actually it is used. So copy options are basically something that tells us, what we have to do, right, during the this operation when we are copying. So I will show you what different options are actually there. So you see this, right? So there are a couple of options, that you can actually pass while during this operation. So first one is atomic move. So either the file will be moved completely, or the operation will get rolled back. It is just like database transaction. Okay. So it will not be possible that that you transfer some partial content of the file to the destination target, and some contents just because your program crashes or something, right, in between. So atomic
Yeah.
option is for that. Copy attributes is that do you want to copy the attributes of the previous file also, right? So there might be some attribute in the file system, correct? So
I didn't got the atomic. Sorry, I didn't got the atomic one.
atomic is like like your database transaction. So let's say you are copying a large file, correct? And your program
Yeah.
basically crashes, right? Somebody turned off the switch or your program crashes for some reason. So what will happen to the file, right? I mean, it will be in an inconsistent state. There is a possibility.
Mm.
right? So what you do is that if you pass the atomic move, either the entire operation will get completed or it will not complete.
Okay.
Okay, so that's why the name atomic. Now, if you want to copy attributes, then you will have to pass the copy attributes. The file system has some attributes, or the more interesting one is replace existing. If there is a file on the target destination which is already there, then if you want to replace that, then you will have to pass this variable. So by default, it is false. Okay.
Yeah.
So I do this, and again it throws an exception because the source file might not be there at all. So sorry. Don't get you. Oh, sorry, my bad. I'm passing the wrong arguments. I have to pass source path. So I will have to call this function. I will call this function inside this tribe cache block itself. So when I say copy file, what I'm going to do is this. So what I will do is that I will create one more nested folder inside it. So let me create a file here first. This is the file that I want to create. So I don't have anything here, right? Now what I'm going to do is that I'm going to run this program. Let's see.
No such files.
Hold on a sec. So it says, oh, okay. I did not save the file, it seems. Oh, now I have the file. Let me run the program again. Surprising. Oh, sorry, my bad. So I'm actually deleting the file. I'll have to comment out this code. I was surprised what is actually happening. So now the program ran fine, no exception, and my original file is still there, right? So now I got folder.txt in this folder itself, right? Correct?
Yeah.
And now I already have a file here. Let me see. Let me change the context. I run the program again. I go to folder 2. I see again the same file, but now I see that it actually replaced it, right?
Yeah.
Because I passed the replace flag in standard copy
Yes.
option. So this is my copy file operation, and similar way we can move a single file or we can move even a directory. Okay.
Yeah.
So this operation, do you want me to demonstrate example for this also? Or? For now, it's fine.
Yeah, it's fine.
Okay. So now that we have seen, so what we have seen is that we have seen like two main classes in the file IO. One is files, another one is paths. Okay.
Yeah,
So path basically helps us to deal with the when we have strings or the file or the folder. Path basically help us to find the actual system path, right? For example, that file exists or not exists. Then I have to actually pass a path variable inside all the files APIs, and that's what the
yeah,
job of the path interface is. But
yeah,
most important function inside path is get, where you will keep passing strings and you will keep getting path object. Okay.
yeah,
Now what we are going to do is we are going to see some example about when we have to walk through the files. Then what? So for now we already knew, right, what is the path of a particular file. But what if we want to walk through? So there are some examples that I have created here. Okay. So let's say I want to list all the files inside a particular directory. Now this part is interesting. So let me start saying list all files, right? And I say string. So inside a folder, I want to walk through all the files and find out their paths in a non-blocking fashion. Okay.
mm,
So what do I do? So now files basically has many interesting APIs, and that one of them is actually list. So if you say that files, the list API actually takes a path. The way I get path is from the paths interface, right? And I pass a
mm,
folder path. But this list, what does it return? If you see list, it actually returns a string,
okay.
right? So now you see that how the functional programming has been married with the non-blocking IO APIs,
Yeah,
right? So now what we have is a standard functional program, because now we have a stream, and on this we can do a lot of things, right? So what we can do is, why it is giving error? Okay, we'll handle that later. So now I want to return. So what I will get is a path. I will say path because I'm getting a stream of paths, right?
yeah,
So this is what I will do, and I will basically collect these results. Let this I will return. Okay. So once I do the list, I get a stream of path, and from that path, I am basically doing a dot to string, and then I collect that into list of string. So I get all the paths. So now let me do this. Whether I file and I use example dot. Sorry, I did not make it static. Now list all files. I path a root folder. Let's say which is this one. Okay. So I will have a list of string file paths, and again let me get a stream from it and let me print it, right? I will run this program and see whether I am able to find. So you see this, right?
Mm, yeah.
So I will comment the time part so that it is more clear if you want. Uh, the, so,
Getting on.
basically, this all might look bit boring to you, but the bottom line is this: that using using the new file API, we are actually able to make our program much more efficient. Okay?
Yeah.
That is something that we are not able to see visibly, but that is something that
Yeah.
will happen in the production environment.
Yeah. Correct.
So and the APIs which are exposed by these packages are very simple to use. Um, so Java has come a long way, right? Because Java file IO also has been bit cryptic right from the beginning. There are many
Yeah.
classes that you have to deal with, and then you have to pass this into that class, that object class, into that class, and you basically keep passing around. And most of the people that I have actually worked with, uh, without documentation, it becomes difficult to work with the Java IO.
Yeah.
So the simplification of the APIs along with hiding the complexity behind the file NIO is something that is that okay. So now we have seen that we can actually list all the files, and one more thing that I actually want to show you is okay. So now we will basically see the usefulness of the walk function. Okay, if you look at the signature of the walk function, walk is also like listing the files because it is also returning a stream of path, correct? But in the walk function there is one extra argument that you can actually define, which is max depth. So you say I am visiting this folder and I want to visit only till depth 2 or depth 1, right? So if I, for example, let's see an example. Okay, so I am inside this folder. Hello Banjish, can you hear me? Hello Manjush. Manjush, hello, can you hear? Hello.
Hello?
Hey,
Yeah,
Manjush.
yeah, I can hear you now.
Okay, okay, okay. So basically, I was talking about this function called walk, and this function has the same signature as list, and it also returns a stream of path. The primary difference is that it also takes a depth.
What's the depth?
Yes, till what depth this will actually iterate.
Oh, okay.
Okay, so let's just see. I am in this folder, and if I go to folder one, I see one more folder, right? So
Yeah,
earlier I was able to print like three files, right? These are the files that
yeah,
I actually got. Now let me
yeah.
see how many files do I get now. So what I will do is I will just convert this function to walk rather than list. Walk all files. Print depth walk folder path. Okay, depth. Sorry. So rather than the list, I will say walk all files. And I will pass. Okay. So now what happens is that it gives me first it gives me all the everything, right? First it gives me the folder, then it gives me a
Yeah,
file inside that folder, then it
yeah.
goes to one depth, it gives me that folder name, and then it gives me one more folder name, right? Which is folder one. Now the point is that I was having folder two as well, right?
Yeah.
But the folder two it did not walk through because I gave the depth as only one.
Oh, okay, okay.
Okay, so if I give depth as two, I should be able to do folder two as well. And let me, just try to do that. Now you see this.
Yeah,
So that's the primary difference between this and that. Um, right. So now we have seen, right, there are some useful functions that are actually given, and I have actually included some other example in the file NIO class, right, which is already checked in. So there is list file. There is find file also, right? And in this find files, basically what you can do is you can give extension, right? You can pass some predicate on the or some condition. So it will only find those files which actually match that condition. Okay. So for example, if
okay.
you see here in files.find, what I have given is that you start at some folder, you provide a max depth till where you actually want to end your widgeting, and then you pass a condition. A condition is here is basically a lambda. It's a lambda because it's expecting a functional interface. Okay, and the condition that I have passed is that give me all the files which are ending with .js. right, whose extension is .u.
mm,
And again it returns me a stream. So all the functions inside um, files class, they basically return you a stream, and you can work on the stream in the same functional fashion as we have been doing so far. Okay,
yeah.
so that's the so yeah, so that's about, I think that's pretty much it about the files. um, so do you have any doubt, you want to ask me any question as of now?
No, okay.
Okay. Okay. Okay. So let's take like a 10 minutes break, and then you want to take a break.
Yeah, sure.
Okay. Let's take some break.
Uh,
Sorry.
just asking about like whether we did an example for non-blocking uh, file example or something.
So I think the better example. Okay. So basically, whatever we have been doing is actually was non-blocking, because we have been dealing with the classes in the non-blocking package, right? Uh,
Yeah, yeah, yeah.
but we have not written any non-blocking code right now, because we actually don't have to deal with it, and that's pretty complex to deal with. Okay.
Mm,
So,
yeah.
but what I'm trying to say is actually that this capability can be demonstrated only in a low test or in production environment.
Mm,
Okay, the benefit that you are actually getting by calling these APIs rather than the older APIs.
yeah.
Okay, but I will try to find probably some more example and send you link. Does it work?
Yeah, that's fine.
So by the way, I will send you these reference links also, so that you, if you want, you can refer to this material whenever, and I find it useful. So okay, so let's take a break. Okay, and then come back
Yeah,
again.
sure. Yeah, sure.
Okay.
Hello.
Hey Manjush.
Yeah.
Okay. All right. So Manjush, we come to our last topic of discussion, which is parallel streams, right? So I told you that we'll touch base upon this briefly, and um, this is a more, what I say is probably more complex topic, and it has to be taken up in the last because it is dependent on the streams. So parallel
Okay.
streams are again streams which run in parallel, right? I mean that's what they are. So
Okay.
first let's see a example that how to get the parallel streams first, right? So what I will do is I will open my gold code uh, insurance premium demo, and we have a premium list. So earlier, if you see that we were doing some stuff with the streams, right?
Yeah.
And if we want to get parallel streams, what we do is rather than the stream function, right? Earlier we were calling
Yeah.
stream function to get streams, but to get parallel streams, we do parallel stream. Okay,
Yeah.
so this is the only difference when we want to do operations on parallel streams or when we want to do operations on the stream. So if we are looking for parallel stream, then we call the parallel stream function. If we are working with stream, we call the stream function, right? Now, so this is about the how we can actually get the instance of the parallel stream. But more important point to understand is that why do we need parallel stream, right? Now when we are working with the functional programming, when we have made sure, this was the one of the basic tenet of functional programming, that we will not deal with the external state, right? That we will have
Yeah.
pure function meaning our output is only dependent on the input that is provided as part of the function arguments, correct? So, because I am following these principles, then if I want to run my program faster, I should be able to get some help, right, from the framework itself. And that is what the parallel streams are. So, for what I'm trying to say is that if I am writing functional program, and if I want to run certain calculations in a parallel fashion, then I should be able to do that using the framework itself, which is the Java 8 APIs.
Okay.
That is why the parallel streams are there. So,
Okay.
uh, but parallel streams now, so parallel streams are nothing, right? They are basically are saying that whatever task you are doing, you should be able to divide that task into multiple smaller tasks and combine them together to get the final result. Okay,
Okay.
that's the basic idea. Now,
So
sometimes it sorry.
yes, yes, please.
So sometimes it might be possible to do that. Sometimes it might not be possible to do that. Because not all the tasks can be parallelized, right?
Yeah.
So few things you say that for example, you are doing sorting, right? So you sort some. So I have like got 10 guys working for me. I give one guy some items. I give another guy some item. I give another guy some item, right? And then say, okay, sort them together, right? And then I want to get the final list in sorted fashion, correct?
Yeah.
So, but the final output that I get might not be sorted at all, right? Because some items, got mixed up.
Yes.
So, what I mean is that when I append the final digits a plus b plus c, that might not be giving me the correct result in the end. So, tasks might not be giving me correct answers when I try to make them run in parallel. So
Yeah.
the basic principles behind whether what can be done in parallel fashion, what cannot be done in parallel fashion is defined by associativity. So associativity is a mathematical abstract algebra concept. So it says that um, it doesn't matter where you put your parentheses, you should be able to get the same output, right? So for example, addition of integers, right? So you say
Uh,
a plus parenthesis b plus c, or you say a plus b into parenthesis plus c, right? Both will give me the
yeah.
same result,
Yes.
right? So that's the bottom line. So that condition has to be satisfied. Only then you would be able to get correct result from parallel streams. Otherwise, every time you run your program, if this does not hold true, then you will get different results.
Okay.
Okay. Benefit of parallel streams is that you do not have to write a lot of multi-threaded code to break your program and collect the results together. In general, what you do, right? So let's say I want to break my program into multiple threads because I have got many cores. So what I will do is that I will the collection that I am working upon, I will break it into smaller chunks. I will give that smaller chunk to one of the threads, right? So I will create 10 threads. To each of the threads, I will give one smaller chunk. When that thread actually gets completed, I will generally call t.join, right? So that I get the result back. And I will call join on all the threads. And once that those joins are completed, I will basically combine that result into some final output. Right? So this makes my program complicated. So parallel streams basically simplify this task, provided the condition that we stated of associativity that holds.
Okay.
Okay. So parallel
Can we
stream,
see an example?
yeah. So I'll come to that. So basically parallel streams, yeah. So let's. So I will show you the basic example.
If I see an example, then I will get some more
Yes.
ideas, and
Yes.
I'll be able to understand the
So
explanation.
let's say
Now
what.
I am just thinking things will go.
Okay. So let me static class parallel stream example, right? And then I have static function static add integers static add integers. Okay, so what I want to do is I want to add some integers in parallel, right? This is what I want to do.
Yeah.
So I get a list of integers. Okay, so I get a list of integers, and from that integers dot I get a parallel stream, right? Then what I want to do is I want to get a, so I do a reduce on it. I get I comma j, right? So what I get is, so reduce is return me an optional of integer sum.
Why it is optional integer?
So basically reduce, so reduce functions. Okay, so yeah, so that's it. So basically the reduce function that we call, right? Reduce, what it does is that it will give you some final output, right? Final output depending on what function you are passing to it. So the function
Okay.
that we are passing to it, that we are trying to add two elements inside the stream, and we keep
Yeah.
adding till we get the final output. But reduce
Yeah.
function does not have any idea whether you will be doing addition, right?
Yeah.
So in reduce you might be doing something else for which there is no element actually exists in the stream itself.
Okay.
So if there does not exist any operation in the stream, any integer, sorry, any element in the stream, then what will you get, right? Either you can return a null or you can return an optional.
Okay.
Okay, so that's why the optional is there. So I have not done the due diligence of checking whether the optional value is present or not. I'm just assuming that it will be present, right? Uh,
Okay.
because we want to show the how the parallel stream actually works. Now what I want to do is I want to call this parallel stream example. So first let me comment this one out, right? File example. So I have a list of dot add some values, right? I mean it doesn't matter. Or let me do a so I created my test data, and then on this test data I want to call the parallel streams, right? And I say pass integer this. Okay. And
Okay.
then whatever the value I get in final result, I just want to so I get a final result, okay, which is some value, right?
Yeah.
So, so from 1 to 10,000, it is actually adding. Uh, Let me do one thing. So you see this, right?
Yeah.
So final result that is actually coming out now is actually same as the one that I was getting previously. Okay, and it does. So right now I am using streams, right? So I use stream or I use parallel stream, I get the same result.
Okay.
Okay, and this is I am getting because the operation that I am doing, this operation is actually associative.
Okay.
Okay, so that's the bottom line around the parallel streams that we are actually. Let's try some other example. Okay, probably that. And parallel streams basically make sure that my program actually runs on multiple cores at the same point of time. That's the beauty about it. If I can show you, let me try. Okay, so I cannot guarantee this, but let me try.
What's support for this theory?
Okay, so basically I will have to run this program inside that demo I have not prepared. Otherwise, I could have actually shown you how many threads actually it is running when we are uh, calling stream and when we are calling parallel stream. So when we
Oh, okay.
okay, when we call
Yeah.
parallel streams, ideally it should be running more number of threads than when that were actually running when we are using only streams. That was the whole. That is the idea.
Once more, once more.
So what number of threads? When I use parallel streams for that on that particular operation, the number of threads should be more than the number of threads which are running in the stream operation. Okay, because parallel streams internally actually launches multiple threads
Yeah.
based on the fork join implementation of Java.
Okay.
Okay, now now we and then the bottom line is I run my program on multiple threads. Still, I am able to get the same result which I was getting through single thread, right?
Yeah.
Now, what we will try to do is that we'll try to see some more examples. So what I will do is let me.
But I didn't get that parallel stream concept exactly. Uh, is it possible to go that execute file that add integers in parallel method?
Yes, so basic. Okay, so parallel stream, what it is doing is that when we are calling this, when we are operating on this stream, right?
Yeah.
When we say parallel stream, so what we get is a parallel stream, right? So the program here, after this, whatever happens, which is the reduce task, right? So reduce
Yeah.
task is doing what? Taking one integer, adding to the next one, then taking that value, then adding to the next one.
Okay.
Correct. So in when
Yeah.
we do parallel stream, what happens is the same thing happens in multiple chunks. So one stream is divided into multiple streams. So
Okay.
let me say, right? I mean, let's say this was my collection, right?
But ultimately, the output will be the same. Only thing is, it works in multiple threads.
And output will be same when the operation that I'm doing on the stream is associative. Otherwise, it will be different.
Oh, okay.
Okay, so let's understand how this is actually working. So when I say stream, what is happening is this is happening. 1 plus 2 will become 3,
Yeah.
right? In the next step, it will become 6, and then it will add it to 4. In the next
Yeah.
step, it will become 10, and
Yeah.
it will add it to 5, like this.
Yeah.
So on. Okay. When we are working with parallel stream, what is happening is first this stream is being divided into multiple smaller chunks. One, two, three, four. I'm just taking a hypothetical scenario. Actual,
Yeah.
it will be dependent on the Java runtime. Okay,
Okay.
but you can say something of this sort: 6, 7, 8, 9, and
Okay.
then
Okay.
one, two
Okay.
will become 3,
Yeah.
and this will become 3 plus 4, 7 plus 5, which will become 12,
Oh. Okay.
and this will become 6 plus 7, 13 plus 8, which will become 21, and then the last element 19, which will become 9, then 30. And then finally I have 3, then I have 3 plus 12 plus 30. Okay, so I take the, so my stream got divided into 3. Each stream's result got evaluated independently of the another one. Now I got 3, I got 12, and I got 30, and the finally I will basically add all of them.
Yeah.
Okay, something of this sort will happen when we are using parallel stream behind the scenes.
Yeah.
Okay, now let me try to create another example for you. So now what I'm doing is, Sorry, let me write another function rather than this one. This will help you to understand it, right? So what I will have is public static list of integers, right? Get sorted integers, right? What we will do is integer string dot sorted dot. In fact, let me just print it. That would be better. Now I'll just reduce it just to get better. Sorry, I didn't even call that. So you see, so what I was trying to do is simply sort the integers. Okay.
Okay.
Now what is the output that I'm getting? Is it sorted?
Yeah.
No, right? Now let's run the same example with streams. Do you see this?
Yeah.
I will always get sorted when I'm using streams because there is no scope for ambiguity here. But when I'm using parallel streams, every time I run, program is actually behaving, differently.
So what is the purpose of coming up with this concept of parallel steps?
So that's what that's what I was trying to explain earlier, right? The purpose of the parallel stream is at times my program may be parallelizable, right? At times I might be able to say that my program can be divided into multiple chunks. Okay. In that case, parallel stream will help me get better performance from my machine because I have got multiple cores on my machine. So the operation that I am running on a single core or a single thread, the same operation is being run on multiple threads using parallel stream without actually doing the multi-threaded programming. So the
Okay.
primary objective of parallel stream would be to divide a bigger task into multiple smaller tasks and get better performance. But the output will be correct only when you know that the operation that you are doing is actually associative. So in
Okay.
the case of addition of integer, that was associative, but in the case of sorting, that was not associative, right?
Yeah.
You got the idea, right?
Yes. Yes.
And the way program is actually divided is dependent on the Java runtime. Now I can show you. Let me show you how this actually happens, right? They're using the same example. Right. My bad. Okay. Um, I'm trying to demonstrate what happens when you. So my integers that actually got printed when I call the this same function, right, with the same argument. My result got printed 140252805 something, right? When
Yeah.
I run the same program again, same code, it prints me something else, some other sequence.
Okay.
Okay, because I am using parallel streams, and parallel stream, it is not guaranteed that in what manner the existing input will be divided. Sometimes it will be divided 140, sometimes it will be divided like 1402528, sometimes it will be divided like 14025, things like that.
Okay.
Okay, so it's the Java runtime which defines in which, from where it will actually break, from where and in how many chunks it will break the given
Yeah.
parameter, right? So that's the primary objective of the parallel stream would be to get benefit from the multiple cores that are available on your machine, but the function that you are actually doing inside the stream operation has to be associated,
Okay.
right? So yeah, so that's about it. I think I have pretty much covered most of the things in the curriculum. Do you have any? So this is what
Uh,
I basically describe you the process of decompose. This is called process of decomposing and then merging, right? With the integer addition example.
yeah.
So yeah. So any questions so far you want to ask me, or
No, if like after going through this test, uh, then when I start working out, and then I will send an email to you.
sure, sure, sure. Yeah. So okay, great. So it was great, Manjush. I mean, you have put a lot of effort, and I believe that you have got benefited from the training in some way.
Yes, yes. Yeah, yeah.
So
I'm very much thankful to you, and as you have given a good explanation on
okay, I'm
these
happy
circuitry.
that I was able to explain to you some of the doubts, and I believe that the new Java 8 features would be able to take you further forward in your career, and I hope that you are able to utilize them in some of your existing projects. That will be great.
Yeah, sure.
So okay, so drop me an email whenever you are done with the assignment, or
Yes, yes, sure, sure. I will do that. I will do that, and I will keep in touch, and I will do more works on this.
okay, okay. So as and when I keep coming out some reference material, in any case, I will be sharing it with you. Okay.
Yes, too.
So
Yeah,
I will check in today's code, and then I will upload today's video as well.
yeah, sure. Then I will, yeah, yeah, I will download that video.
Okay. Okay, Manjush.
Thanks,
Have
thanks a million, thanks a million.
have a great day ahead. Okay. All the best.
Yeah, thank you. Thanks a million.